Hi there, I'm Mirko Peters, founder of Data and Analytics, where we turn data into decisions and analytics into action. Over the years, I've helped businesses and professionals leverage the power of AI, machine learning, and data science, and today I'm here to help you do the same. Let me ask you this. Have you ever wondered what powers AI, how machine learning works behind the scenes, or how these tools can completely transform your career or business? This video is your ultimate guide to navigating the landscape of AI, machine learning, and deep learning. Here's why you should stick around. You'll uncover the key differences between AI, ML, and DL. Learn how these technologies are revolutionizing industries like healthcare, finance, and marketing, and discover how mastering these skills can open exciting career opportunities, whether you're just starting out or looking to level up. Oh, and don't forget to hit that subscribe button for more insights on data-driven success. While you're at it, drop a comment below with topics you'd love me to cover next. I'm here to help you achieve your goals. Let's dive in. First, we'll break down the foundations of AI, ML, and DL and how they can power your success. When should we upload the first slide? Let's create something that inspires action and gets people saying, "This is exactly what I needed." You walk into a bustling hospital, doctors and nurses are rushing through the halls, patients are waiting, and data flows constantly. Test results, medical histories, and diagnoses. A young physician hesitates as they review a complex case, unsure of the best treatment path. Suddenly, they consult a system powered by artificial intelligence. Within seconds, it identifies patterns in millions of similar cases, offering insights that even the most experienced doctors might miss. The physician acts confidently, knowing they're making a data-backed decision. This isn't science fiction, it's happening right now. AI is revolutionizing industries in ways we couldn't have imagined even a decade ago. But here's the key. Not all AI is the same. Understanding its layers, AI, machine learning, and deep learning is crucial to seeing how this transformation unfolds. Artificial intelligence, at its core, is the simulation of human intelligence in machines. It encompasses everything from rule-based systems to advanced robotics. It's like giving a machine the ability to reason, learn, and adapt, tasks we once thought were unique to humans. Now, within AI lies something even more transformative: machine learning. Think of it as teaching a machine how to recognize patterns without telling it what to look for. It's like showing a child countless images of dogs until they just know what a dog looks like. Over time, the system improves, learning from its successes and failures. But then there's deep learning, a specialized part of machine learning. It doesn't just look at patterns, it dives deeper, mimicking the way our brain's neural networks process information. This is why deep learning systems can drive cars, recognize your face in a photo, and even translate languages in real time. They don't just learn, they interpret, adapt, and grow. Take a moment to think about the systems you interact with daily. Every time Netflix suggests a show you love, or Google Maps finds the fastest route, machine learning is at work. When your phone understands your voice commands or enhances the lighting in your selfies, deep learning steps in. These technologies are already embedded in our lives and their influence is only growing. So why is this important? Because understanding the nuances between AI, machine learning, and deep learning isn't just for tech enthusiasts. It's for anyone who wants to grasp the forces shaping the world around us. It's the foundation for industries of the future, from autonomous vehicles to predictive healthcare and even the creative arts. In the coming slides, we'll break these concepts down further, unpacking their key differences, their real-world applications, and how they work together to create the AI-powered world we're stepping into. Picture this. You're at an airport, waiting to board your flight. As you hand over your ticket, the system scans your boarding pass and matches it with your face. It happens so quickly, you don't even think about it. Behind the scenes, however, there's an intricate dance of algorithms analyzing your features, confirming your identity, and ensuring everything is in order. This is artificial intelligence at work, silent, swift, and seamless. But what exactly is AI? At its simplest, AI is about machines that can perform tasks requiring intelligence, tasks we once thought only humans could handle. It's not just about replicating human actions, it's about mimicking the way we think, reason, and adapt. Let's break this down. Artificial intelligence refers to systems designed to learn, reason, and correct themselves. They can absorb data, process it, and make decisions without constant human input. Imagine teaching a machine to recognize traffic lights. It learns through exposure to thousands, sometimes millions, of images, refining its ability to distinguish red from green over time. But there's more to AI than just pattern recognition. It's also about reasoning, using rules to reach conclusions. Take the example of a weather prediction system. By analyzing historical patterns and applying logic, it can forecast tomorrow's conditions with impressive accuracy. And when it's wrong, it adjusts, improving with every misstep. Here's where it gets exciting. AI is not a monolithic concept. It's made up of layers, each with a distinct role. At one level, we have machine learning, where systems learn from data and identify patterns. At another, there's deep learning, which uses multi-layered neural networks to dive into complex tasks like understanding speech or recognizing faces. Think of it like peeling an onion. The outer layer is AI, the broad concept of machine intelligence. Inside, you'll find machine learning, which teaches machines to learn from experience. And at the core, there's deep learning, with its ability to analyze unstructured data like images and sound. Now, let's connect this to the real world. AI isn't just for high-tech labs or futuristic gadgets. It's reshaping industries right now. In healthcare, AI-powered tools assist doctors in diagnosing diseases, often spotting what the human eye might miss. In finance, algorithms detect fraudulent transactions within milliseconds, protecting businesses and customers alike. And in customer service, chatbots powered by AI handle queries around the clock, making support more efficient than ever. So when we talk about AI, we're not just talking about machines performing tasks. We're talking about a system that learns, adapts, and evolves, paving the way for a smarter, more connected world. In the next slide, we'll dive deeper into how AI has evolved from its earliest days to the breakthroughs that define the present. Ready to explore the journey of AI? Imagine sitting in a dimly lit room in the 1950s where a small group of visionaries gathers to answer a bold question. Can machines think? This moment marked the birth of artificial intelligence, a field that would evolve from academic curiosity into one of the most transformative forces in human history. It all began in the 1950s with the introduction of the Turing test by Alan Turing. This was a groundbreaking moment, a way to determine if a machine could exhibit intelligent behavior indistinguishable from that of a human. Soon after, at the Dartmouth Conference in 1956, the term artificial intelligence was officially coined. These early pioneers dreamed of creating machines that could reason, solve problems, and even understand language. But let's be honest, AI back then was limited by technology. Computers were slow and data was scarce. The ideas were there, but the tools were not yet ready. Fast forward to the 1980s and the narrative shifts. This was the era of machine learning, where the focus moved from hard-coding rules to teaching machines how to learn from data. A key breakthrough was the introduction of the backpropagation algorithm, which allowed neural networks to adjust and improve based on errors. It was like teaching a toddler to walk by learning from every stumble. This shift meant that machines could now learn patterns without being explicitly programmed. The implications were massive, setting the stage for what was to come. Enter the 2010s, and the story becomes even more compelling. This was the age of deep learning, powered by advances in computational power and data availability. Neural networks, now with many layers, hence the term deep, began outperforming traditional machine learning methods in tasks like image and speech recognition. Think about the first time you used a voice assistant like Siri or Alexa. Deep learning was working behind the scenes, analyzing your voice and responding intelligently. Self-driving cars, facial recognition, and even personalized content recommendations all became possible because of this leap forward. And now we find ourselves in the 2020s, an era defined by large language models, LLMs, like GPT-3. These models are trained on billions of parameters, enabling them to generate human-like text, translate languages, and even write code. It's as if these systems have unlocked a new level of understanding, transforming industries and the way we interact with technology. When we look back, it's clear that the journey of AI has been one of persistence, breakthroughs, and continuous evolution. From Turing's foundational ideas to the powerful language models of today, AI has moved from science fiction to everyday reality. In the next slide, we'll dive deeper into machine learning, the engine that powers much of this evolution. Ready to explore the mechanics of how machines learn? You're scrolling through your favorite streaming platform and suddenly a suggestion pops up. We think you'll love this movie. You click play and it's spot on. How did they know? It feels like magic. But behind the scenes, it's machine learning, the technology that allows systems to learn about you and adapt. At its core, machine learning (ML) is a subset of artificial intelligence. Think of it as teaching a machine to learn from data, identify patterns, and make decisions, all without being explicitly programmed. For example, let's say we're teaching a system to predict whether an email is spam. Instead of creating endless rules for every spam scenario, we feed it examples, thousands of spam and non-spam emails. The machine learns the patterns, like certain phrases, email structures, or links, and applies that knowledge to new emails. Over time, the system improves, learning from mistakes and adapting to new types of spam. That's the beauty of ML. It doesn't just follow instructions, it evolves. But machine learning isn't a one-size-fits-all solution. There are three main types. Supervised learning. Imagine teaching a child to recognize fruits. You show them labeled examples. This is an apple and this is an orange. Over time, they learn to identify fruits based on these examples. Similarly, supervised learning involves training a machine on labeled data to predict outcomes like classifying emails or forecasting sales. Unsupervised learning. Now, imagine you hand the child a basket of fruits but don't label them. They start grouping them. Apples with apples, oranges with oranges. That's unsupervised learning. The machine identifies patterns or clusters in data without explicit labels. It's often used for things like customer segmentation or anomaly detection. Reinforcement learning. This is like teaching a dog to fetch. The dog tries different behaviors, and when it does the right thing, it gets a treat. Reinforcement learning involves an agent learning by interacting with its environment, aiming to maximize rewards. It's used in areas like robotics, game strategy, and even stock trading. So, where does machine learning show up in the real world? Everywhere. In healthcare, ML helps doctors predict diseases, personalize treatments, and analyze medical images. In finance, it detects fraud, scores credit, and even drives algorithmic trading. And in marketing, ML powers recommendation engines, customer segmentation, and sentiment analysis. Here's a fun fact. Every time you binge watch a series or see a product ad tailored just for you, ML is silently working in the background, analyzing your behavior and delivering exactly what you didn't know you needed. Machine learning isn't just about programming machines to do tasks, it's about creating systems that adapt, grow, and learn from experience. It's the engine driving much of today's AI revolution. In the next slide, we'll dive deeper into deep learning, a specialized subset of machine learning that takes this adaptability to an entirely new level. Ready to explore? Imagine watching a toddler learn to recognize a cat. At first, they might mistake a dog or even a stuffed animal for a cat, but over time, as they see more and more examples, they refine their understanding. They begin to notice details, like the shape of the ears, the way a cat moves, or the sound it makes. This process of learning through layers of understanding is strikingly similar to how deep learning works. Deep learning is a subset of machine learning, but it's in a league of its own. While traditional machine learning relies on predefined features to make predictions, deep learning takes it a step further. It learns those features itself. It's powered by neural networks, complex, multi-layered systems inspired by the structure of the human brain. Think of it like this. Each layer of the network processes information and passes it on to the next, much like neurons in our brain. The first layer might detect simple shapes, the next might combine those shapes into objects, and the final layer identifies what it all means. That's a cat. The more layers, or depth, the network has, the more nuanced its understanding becomes. To understand how deep learning works, let's break it down into key components. Neural networks. These are the building blocks of deep learning. Each neuron in the network takes in data, processes it, and sends the result to the next layer. Together, these neurons work like a giant brain, analyzing data step by step. Training data. Deep learning thrives on data, lots of it. To teach a network to recognize faces, for example, you'd feed it thousands or even millions of labeled images. The network learns patterns and features through repetition. Computational power. Training these networks requires immense processing power. That's where GPUs, graphics processing units, come in, enabling networks to process vast amounts of data quickly. But where does all this complexity lead? Deep learning is behind some of the most groundbreaking technologies of our time. Here are a few examples. Computer vision. Deep learning powers image recognition, object detection, and even medical image analysis, helping doctors identify tumors with unprecedented accuracy. Natural language processing, NLP. Every time you use a voice assistant, translate a language, or get a chatbot's help, deep learning is at work. Understanding and generating human language. Autonomous vehicles. Self-driving cars rely on deep learning to process visual data, predict movements, and navigate complex environments. These systems don't just follow rules, they adapt to the complexities of real-world data, making them incredibly versatile. But where does all this complexity lead? Deep learning is behind some of the most groundbreaking technologies of our time. Here are a few examples. Computer vision, deep learning powers image recognition, object detection, and even medical image analysis, helping doctors identify tumors with unprecedented accuracy. Natural language processing, NLP. Every time you use a voice assistant, translate a language, or get a chatbot's help, deep learning is at work, understanding and generating human language. Autonomous vehicles. Self-driving cars rely on deep learning to process visual data, predict movements, and navigate complex environments. These systems don't just follow rules, they adapt to the complexities of real-world data, making them incredibly versatile. Of course, deep learning comes with its own set of challenges, data requirements. To perform well, these networks need massive amounts of data. Without it, their accuracy can drop. Overfitting. Sometimes a network becomes too good at recognizing patterns in the training data, but struggles with new, unseen data. Techniques like regularization and dropout help address this. Computational costs. Training a deep network can be expensive, requiring both time and resources. This is why companies invest heavily in infrastructure to support it. Deep learning isn't just a buzzword, it's a transformative approach to solving problems that were once thought to be impossible for machines. It's the key to unlocking technologies like autonomous vehicles, intelligent assistants, and even creative tools that generate art and music. In the next slide, we'll explore how AI and machine learning compare, uncovering their similarities and distinctions. Let's continue the journey. Let's imagine you're running a high-tech bakery. You're the owner overseeing the entire process. You decide which recipes to use, which ingredients to buy, and how the whole operation works. That's artificial intelligence, the big picture orchestrator that mimics human decision making. Now, within your bakery, you have a head chef who learns from experience. Maybe they've baked 1,000 loaves of bread and over time figured out the perfect balance of ingredients to achieve the best flavor. That's machine learning, the specialist that improves with practice, handling specific tasks with precision. Artificial intelligence is the overarching concept. It's the idea of creating machines that can think, learn, and adapt like humans. It encompasses a wide range of fields: natural language processing, robotics, computer vision, and more. AI is like the conductor of an orchestra. It doesn't just focus on one instrument or section. It brings everything together to achieve a harmonious result. It's not just about solving a single problem, but enabling machines to make decisions, reason, and act intelligently across diverse scenarios. Think of self-driving cars. AI manages the entire system, deciding when to accelerate, when to brake, and how to respond to complex traffic scenarios. It's a symphony of intelligence that brings all the pieces together. Now let's zoom into machine learning, ML, a subset of AI that focuses on teaching machines how to learn from data. Unlike traditional programming, where we explicitly tell machines what to do, ML lets the machines figure it out themselves. Here's an example. Imagine you're trying to teach a machine to recognize spam emails. In traditional programming, you'd write a long list of rules, flag emails with certain keywords, strange formatting, or suspicious links. But with ML, you give the machine a data set of emails labeled as spam or not spam. Over time, it learns the patterns and makes predictions on its own. Machine learning isn't concerned with the big picture like AI. It's laser-focused on specific tasks like predicting stock prices, recognizing faces, or suggesting the next song in your playlist. Here's how they differ. Scope. AI is the umbrella term, encompassing all machine intelligence, while ML is a specialized subset focused on learning from data. Functionality. AI systems can be rule-based or data-driven, but ML is always about improving performance through data. Examples. AI is like the CEO of a company, overseeing strategy and decision-making. ML is the department head, mastering a specific area like marketing, sales, or operations. In short, AI is the architect and ML is the builder. AI defines the vision, while ML focuses on the execution. Together, they're shaping the future of technology in ways that are both exciting and transformative. In the next slide, we'll take this one step further and compare AI with data science, exploring how these fields intersect and complement each other. Let's keep going. Imagine you're planning a road trip. To make it successful, you need two key things: a navigator who helps you plan the best route and predicts obstacles ahead, and a driver who takes you to your destination. This is the relationship between data science and artificial intelligence. Data science is the navigator. It collects and analyzes data to guide the journey. AI is the driver. It takes action based on the insights provided, navigating through dynamic environments and adapting as needed. Together, they make the journey smarter, smoother, and more efficient. Let's start with data science. At its core, it's an interdisciplinary field that focuses on extracting knowledge and insights from data, whether it's structured numbers or unstructured text and images. Data science combines techniques from statistics, mathematics, and computer science to uncover patterns and tell a story. Think of it as the detective of the digital world. A data scientist looks at a messy data set, cleans it up, and finds hidden clues that can guide decisions For example, in retail, a data scientist might analyze sales data to predict future trends or segment customers based on buying behavior. It's about making sense of chaos and transforming it into actionable insights. Now, compare this to artificial intelligence, which goes beyond insights. AI takes those insights and applies them to make decisions, automate processes, or solve problems in real time. While data science looks at historical data to explain what happened and why, AI focuses on what's happening now and what's likely to happen next. Imagine a self-driving car. Data science helps analyze traffic patterns, road conditions, and sensor data to map out the safest routes. AI takes that information and uses it to steer the car, avoid obstacles, and adjust to changing conditions in real time. So how do they differ? Purpose. Data science is about understanding data, while AI is about acting on that understanding. Approach. Data science uses models and algorithms to analyze data, while AI applies those models to automate tasks and make decisions. Outcome. Data science provides insights, AI delivers intelligent systems. The magic happens when AI and data science come together. Consider Netflix. Data science analyzes viewing habits to identify patterns, what genres are trending, how long people watch, and what they're likely to enjoy. AI takes that data and powers the recommendation engine, suggesting the perfect show or movie for you at just the right time. In healthcare, data science analyzes patient records to find patterns in symptoms and treatments. AI then uses that data to create personalized care plans, predict potential health risks, and even assist in diagnosing diseases. In summary, data science is the compass guiding us with insights, while AI is the engine driving us forward with intelligence. Together, they're transforming industries and reshaping the way we live and work. Next, we'll explore how machine learning and data science compare and complement each other. Let's dive deeper into their intersection. Picture yourself as the head of a futuristic restaurant. Your chef is brilliant at preparing dishes, constantly improving recipes by learning from customer feedback. That's machine learning, mastering a specific skill through data. But behind the scenes, your operations manager is analyzing customer trends, supply chains, and financial data to guide the restaurant's strategy. That's data science, uncovering patterns to drive better decision-making. While they seem like separate roles, their collaboration is what makes the restaurant a success. This is how machine learning, ML, and data science interact. They complement each other while serving distinct purposes. Let's start with data science. It's all about the broader picture, analyzing data to uncover trends, predict outcomes, and answer critical questions. Data scientists take raw data, clean it, explore it, and use techniques from statistics and machine learning to extract meaningful insights. Think about a data scientist working in e-commerce. They might analyze customer purchase histories to identify trends like customers who buy product A are likely to buy product B. Using this insight, they can recommend the right products, stock inventory efficiently, and optimize marketing strategies. Data science doesn't just find the what, it digs into the why, giving organizations a roadmap to follow. Now, compare this to machine learning, which zooms into specific tasks. ML builds predictive models that learn from data and improve over time. Unlike data science, which often stops at insights, machine learning uses those insights to make automated decisions or predictions. For example, in the same e-commerce scenario, machine learning powers the recommendation engine. When you browse for a new pair of shoes, ML predicts what other products you might want based on patterns from millions of other customers. It's not just about understanding the data, it's about acting on it in real time. Here's how they differ. Focus. Data science is broader, focusing on analyzing and interpreting data to answer strategic questions. Machine learning is narrower, focusing on building models to automate predictions and decisions. Tools. Data science uses statistical techniques, visualization tools, and sometimes machine learning models to analyze data. Machine learning relies on algorithms and models that improve with data. Goal: data science is about understanding and guiding strategy. Machine learning is about automation and execution. The power of data science and machine learning comes alive when they work together. Take retail forecasting, for example. Data science identifies trends like seasonal spikes in demand for certain products. Machine learning takes this insight and predicts specific inventory needs for each store, automating orders and ensuring shelves are stocked at the right time. In healthcare, data science analyzes patient records to discover risk factors for diseases. Machine learning uses this information to build predictive models that identify high-risk patients in real time, enabling early interventions. In essence, data science is the strategist, uncovering patterns and insights, while machine learning is the practitioner, applying those insights to create intelligent systems. Together, they're driving innovation and solving problems at scale. In the next slide, we'll dive into the exciting world of large language models, LLMs, where machine learning meets advanced natural language processing. Let's explore how these systems are changing the way we interact with AI. Imagine asking a machine to write a poem, summarize a research paper, or translate a complex document into another language, and it delivers almost effortlessly. This is the magic of large language models, LLMs, AI systems designed to understand and generate human-like text, unlocking a new frontier of possibilities. LLMs represent the next leap in artificial intelligence, where machines not only process data, but engage with it at a human level. So, what are LLMs? At their core, they are advanced AI models trained on enormous datasets of text, everything from books and articles to conversations. They learn patterns, context, and the intricacies of language, enabling them to generate coherent and contextually accurate text. Think of LLMs as the world's most well-read assistant. They don't just memorize, they synthesize. Whether you're asking them to draft a business proposal or explain a complex concept in simple terms, they draw on their vast training to deliver. What makes LLMs so powerful? Two key features stand out: scale and complexity. LLMs are trained on billions of parameters, capturing nuances in language that smaller models can't. This allows them to handle a wide range of tasks, from answering technical questions to engaging in creative writing. Versatility. LLMs can perform a variety of functions, summarizing lengthy documents into concise points, translating languages with incredible accuracy, answering questions in a conversational and natural tone. In essence, LLMs don't just understand, they interact, adapt, and respond. The real-world applications of LLMs are transformative. Here are a few examples. Content creation. LLMs like GPT-3 power tools that generate articles, blog posts, and even creative works like poetry and stories. Customer support. They enable chatbots and virtual assistants to provide real-time intelligent responses, enhancing user experience. Research and education. LLMs help researchers sift through vast amounts of information, summarizing key insights and enabling faster decision-making. From businesses to education, LLMs are becoming indispensable in streamlining workflows and unlocking creativity. But as with any powerful tool, LLMs come with challenges. Bias and misinformation. Since they learn from existing data, LLMs can unintentionally reinforce biases or generate misleading content. Ethical concerns. Questions around the responsible use of LLMs, such as preventing misuse in creating fake news or harmful content, are critical to address. These considerations remind us that while LLMs are tools of immense potential, they require careful and ethical implementation. Looking ahead, advancements in LLMs will further enhance their capabilities, making them even more accurate, creative, and efficient. Imagine models that not only generate text but understand the emotional context, enabling deeper and more meaningful interactions. In the next slide, we'll delve into generative AI, where LLMs play a pivotal role in reshaping creativity and content generation. Let's dive deeper into this transformative space. Imagine a world where machines not only analyze data but actively create, composing music, designing stunning visuals, or even writing compelling stories. Welcome to the world of generative AI, where creativity meets computation, unlocking possibilities we never thought possible. So, what is generative AI? Unlike traditional AI, which focuses on predicting outcomes or classifying data, generative AI does something unique. It creates. It uses learned patterns to generate entirely new outputs: text, images, music, and more. Think of it as an artist inspired by millions of paintings, composing an original masterpiece that feels both familiar and novel. Generative AI isn't about replication. It's about innovation. Generative AI is powered by groundbreaking technologies, including large language models, LLMs. These are the text-generating giants like GPT-3, capable of crafting anything from poetry to business reports. They specialize in understanding and producing human-like language, generative adversarial networks in GANs. Imagine two networks in creative competition. One generates content and the other critiques it. This dynamic results in hyper-realistic outputs, from photorealistic images to video content. These technologies enable generative AI to stretch the boundaries of what machines can do creatively. The applications of generative AI are as vast as they are impactful. Content creation. Tools powered by generative AI are writing articles, generating marketing copy, and even creating social media posts. It's like having a 24/7 creative assistant, art and design. Tools like DALL-E and Midjourney are enabling users to create stunning visuals from simple text prompts, democratizing creativity. Media and entertainment. Generative AI is composing original music, designing characters for video games, and even assisting in screenwriting. Generative AI is not just automating creativity, it's amplifying it, allowing humans to focus on imagination and strategy. But as with any transformative technology, generative AI comes with challenges, ethical concerns. How do we prevent misuse, such as creating deepfakes or plagiarized content? The potential for harm is as significant as the potential for good. Bias and quality control. Generative AI learns from existing data, which means it can inadvertently perpetuate biases or produce inaccurate outputs. Navigating these challenges requires responsible development and thoughtful regulation to ensure generative AI benefits society as a whole. Welcome to the new era of video creation with Jog AI. Simply type your script to get started. AI is like a multi-tool, each blade designed to solve a specific problem. From analyzing language to recognizing images, predicting trends, and even creating content, AI tools are reshaping industries and enabling us to do more than ever before. Let's break down the key tools and applications of AI and see how they're transforming the way we work and live. Natural language processing, NLP. Imagine talking to your virtual assistant and it instantly understands your needs. That's NLP, a tool that enables machines to interpret and respond to human language. Applications include chatbots, resolving customer issues in real time. Sentiment analysis, helping businesses understand public opinion. Language translation, bridging gaps between people worldwide. NLP turns human language into actionable insights, connecting people and machines like never before. Computer vision, picture a self-driving car identifying road signs, a smartphone unlocking with facial recognition, or a medical system detecting diseases from scans. These are all examples of computer vision. Applications include facial recognition, enhancing security and personalization. Medical imaging assisting doctors in diagnosing conditions like cancer, autonomous vehicles navigating complex environments with real-time visual data. Computer vision doesn't just see, it understands, making it a cornerstone of modern AI. Predictive analytics. What if you could predict the future, not with a crystal ball, but with data? Predictive analytics does exactly that, using historical data and AI to forecast trends and risks. Applications include finance, scoring credit, and detecting fraud; marketing, segmenting customers and personalizing campaigns; healthcare, predicting patient outcomes and optimizing care plans. Predictive analytics helps businesses make smarter decisions by turning raw data into actionable foresight. Together, these tools represent the breadth of AI's capabilities. They don't just automate, they elevate, helping industries solve problems, enhance efficiency, and unlock innovation. In the next slide, we'll delve into data science concepts, exploring how this interdisciplinary field underpins AI's decision-making and analytical power. Let's dive deeper into the science behind the magic. Have you ever wondered how businesses make data-driven decisions, from predicting market trends to personalizing your online experience? It's all powered by data science, the discipline of extracting knowledge and insights from data to drive smarter strategies. Let's start with the fundamentals. What is data science? At its core, data science is an interdisciplinary field that uses scientific methods, algorithms, and systems to extract insights from structured and unstructured data. It combines statistics, programming, and domain expertise to uncover patterns and make informed decisions. For example, imagine a retail company analyzing sales data to identify trends. Data science doesn't just show them what sold well, it helps explain why certain products performed better and predicts what might sell in the future. It's the perfect marriage of science and storytelling, where data tells a tale and businesses act on it. What makes data science so powerful? It's built on several key components: statistics and mathematics, the foundation for analyzing data, identifying trends, and making predictions; programming, tools like Python, R, and SQL enable data scientists to manipulate and visualize data efficiently; machine learning, the engine that automates pattern recognition and prediction, giving data science its predictive edge; big data technologies, platforms like Hadoop and Spark allow the processing of massive datasets, unlocking insights that were previously out of reach. Data science is like a toolbox, and each component plays a critical role in crafting solutions. But what makes data science indispensable is its ability to turn data into actionable decisions. Here's how it works. Data-driven decisions. Organizations use data science to identify opportunities, reduce risks, and optimize operations. For example, a logistics company might analyze delivery routes to minimize costs and improve efficiency. Impact on business. According to a McKinsey report, companies that use data-driven decision-making are 23 times more likely to acquire customers, times more likely to retain them, times more likely to be profitable. Data science transforms data from a byproduct of operations into the driving force behind strategic growth. Think about Netflix. Every time you watch a show, data science analyzes your preferences, compares them with millions of other viewers, and recommends your next favorite series. It's not just guessing, it's science in action. Or consider healthcare. By analyzing patient data, hospitals can predict outbreaks, personalize treatments, and even prevent illnesses before they occur. From marketing and finance to healthcare and beyond, data science isn't just supporting decisions, it's leading them. In the next slide, we'll focus on AI for beginners, taking a step back to explore the basics of AI and its everyday applications. Let's continue the journey. Imagine trying to explain artificial intelligence to someone who has never heard of it before. Where would you start? AI may seem complex, but at its heart, it's simply about making machines smart, helping them think, learn, and solve problems like humans. Let's break it down step by step. What is AI? At its core, artificial intelligence is about simulating human intelligence in machines. It enables computers to perform tasks like reasoning, problem solving, and even understanding language. Think of it as teaching a robot to recognize faces, drive a car, or even hold a conversation. AI encompasses various technologies, including machine learning and deep learning, that work together to achieve these goals. Here's a simple analogy. AI is like a virtual assistant in your phone. It listens to your commands, processes your requests, and learns to serve you better over time. From playing your favorite playlist to reminding you about meetings, AI enhances your everyday life in countless ways. To understand AI, let's look at its key building blocks: machine learning, ML. This is a subset of AI focused on teaching machines to learn from data. Think of it as training a dog, showing it examples, rewarding it for getting it right, and helping it improve over time. ML powers everything from recommendation systems to fraud detection. Deep learning, DL, a specialized branch of ML that uses neural networks to analyze large amounts of data. It's what enables AI to recognize faces, translate languages, and even create art. Deep learning dives deep into patterns, uncovering insights traditional methods might miss. These concepts make AI more than just code. They make it adaptive, dynamic, and intelligent. AI isn't just for scientists or engineers, it's already a part of your daily routine. Here are a few examples. Virtual assistants: Alexa, Siri, and Google. Assistant use AI to understand your voice, answer your questions, and perform tasks like setting reminders. Recommendation systems: platforms like Netflix and Amazon analyze your preferences and suggest movies or products tailored to you. Autonomous vehicles: AI helps self-driving cars navigate roads, recognize obstacles, and make split-second decisions. These applications show how AI simplifies tasks, saves time, and enhances convenience in ways we now take for granted. In essence, AI isn't as intimidating as it sounds. It's about teaching machines to do what humans do: reason, learn, and adapt. From your smartphone to your streaming service, AI is woven into the fabric of modern life, making it more efficient and personalized. In the next slide, we'll zoom in on machine learning for beginners, exploring how this powerful subset of AI works and what makes it so transformative. Let's dive deeper. Imagine teaching a child to identify animals. At first, you show them pictures of cats and dogs, pointing out the differences. Over time, they learn to recognize these animals on their own, even in new contexts. This is essentially what machine learning, ML, does, teaching machines to learn patterns from data and make decisions without being explicitly programmed. So, what is machine learning? It's a subset of artificial intelligence that focuses on building systems that learn and improve from data. Rather than programming specific instructions, you train a model with examples, allowing it to identify patterns and make predictions. For instance, a spam filter learns to identify unwanted emails based on previous examples. A recommendation system like Netflix learns your preferences by analyzing what you've watched and rate it. Machine learning is like having a self-improving assistant. It gets better with experience. Machine learning can be divided into three main types, each tailored for different problems. Supervised learning. Think of it as learning with a teacher. You provide labeled data, e.g., pictures of animals labeled as cat or dog, and the model learns to classify new data based on those examples. Examples: email spam detection, fraud detection. Unsupervised learning. Here, the machine has no teacher. It explores unlabeled data to find patterns and groupings, much like discovering clusters in a puzzle. Examples: customer segmentation, anomaly detection. Reinforcement learning. This is learning by trial and error. The model interacts with its environment, learning from rewards and penalties to achieve a goal. Examples: self-driving cars, game-playing AI. These approaches make machine learning adaptable to a wide range of tasks. Let's look at the foundational concepts that power machine learning algorithms. These are the mathematical recipes that process data and make predictions. Examples include linear regression, predicts continuous outcomes, e.g., housing prices. Decision. Trees. Classifies data into categories, e.g., whether a loan applicant is eligible. Evaluation. Metrics. Tools like accuracy and precision assess how well the model performs, ensuring it's reliable and effective. Data quality. Remember, garbage in, garbage out. The quality of the training data directly impacts the model's accuracy. Cleaning and preparing data is a critical step. Machine learning is everywhere. It powers personalized shopping experiences through product recommendations, advanced medical diagnostics, predicting diseases from patient data, smart assistants like Siri that get better at understanding your voice over time. It's not just a buzzword, it's the driving force behind much of today's AI innovation. In the next slide, we'll explore data science careers, highlighting the skills and opportunities in this exciting field. Let's see where your data journey could take you. Data is often called the new oil, but like oil, it needs refining to unlock its true value. That's where data science careers come in. These roles are at the intersection of technology, business, and strategy, helping organizations make smarter decisions, predict trends, and innovate faster. Let's explore the pathways that make data science one of the most sought-after fields today. Data science is not a one-size-fits-all career. It encompasses a variety of roles, each with its own unique focus. Here are some key positions. Data analyst, the storyteller of data. Analysts interpret numbers, create visualizations, and deliver actionable insights. They focus on answering questions like, why did sales spike last quarter? Data scientist, the problem solver. Scientists design machine learning models, predict outcomes, and tackle complex challenges like, how can we improve customer retention? Machine learning engineer, the builder. Engineers deploy machine learning models into production, ensuring they work seamlessly in real-world environments. These roles highlight the versatility and depth of the data science field. What does it take to succeed in data science? Let's break it down. Technical proficiency. Programming languages like Python and R are must-haves for manipulating and analyzing data. Tools like SQL help manage databases, while frameworks like TensorFlow enable machine learning development. Statistical knowledge. Understanding statistical methods is key to uncovering trends and making accurate predictions. Communication skills. It's not enough to analyze data. You need to communicate your findings effectively to stakeholders who may not have a technical background. Think of these skills as the toolkit for turning raw data into real-world impact. Why pursue a career in data science? The opportunities are endless, high demand. Data science roles are projected to grow by 28% by 2026, driven by the increasing reliance on data-driven decision-making. Versatile applications. Whether it's finance, healthcare, marketing, or technology, data scientists are needed across industries. For instance, in healthcare, they predict patient outcomes. In marketing, they optimize campaigns for better ROI, lucrative salaries. With demand far exceeding supply, data scientists enjoy some of the highest salaries in the tech industry. Data science isn't just a job, it's a gateway to innovation and impact. In summary, data science careers offer a blend of creativity, problem-solving, and technical expertise. Whether you're analyzing trends, building models, or communicating insights, you'll be at the forefront of shaping the future. In the next slide, we'll look at AI tutorials and learning resources, diving into the tools and platforms that can help you kickstart or advance your journey. Let's explore how to grow your skills. Learning AI is like unlocking a treasure chest. You just need the right map. Whether you're a beginner exploring the basics or a professional diving into advanced concepts, there's no shortage of resources to guide you. Let's explore some of the best tools and platforms to grow your skills in AI and data science. Online courses, platforms like Coursera, ADX and Udacity offer comprehensive courses designed to help you master AI concepts step by step. Popular options include Andrew Ng's Machine Learning course, a beginner-friendly introduction to the fundamentals of ML deep learning. Specialization for those ready to dive into neural networks and advanced architectures. These courses are like structured roadmaps, guiding you from foundational knowledge to practical applications. Books and ebooks. For those who love to learn at their own pace, books offer a wealth of knowledge. Artificial Intelligence, A Modern Approach by Stuart Russell and Peter Norvig. The Definitive Guide to AI Principles and Techniques. Deep Learning by Ian Goodfellow, Yoshua Bengio, and Aaron Corville, a must-read for anyone looking to understand the mechanics of neural networks. Think of these as your AI companions, ready to provide deep insights whenever you need them. YouTube channels and podcasts. Sometimes the best way to learn is through bite-sized videos and discussions. Here are some top recommendations. YouTube channels, 3 Blue 1 Brown, visual explanations of complex AI and math concepts. Centex, tutorials on Python and machine learning projects. Data and analytics. You are here, click the subscribe button. Podcasts. Data, Skeptic, interviews with AI experts on current trends. WIML AI podcast, discussions on cutting-edge research in machine learning. These resources are perfect for learning on the go or during your daily routine. Interactive platforms and tools. Hands-on practice is essential, and platforms like Kaggle and Google Colab make it easy. Kaggle. Compete in data science challenges, access datasets, and learn from the global community. Google Colab, a free cloud-based tool for coding and training AI models without needing powerful hardware. Tools like TensorFlow and PyTorch provide extensive documentation and community support to help you build and train models. These platforms turn theory into practice, letting you experiment and innovate in real time. The journey to mastering AI doesn't have to be overwhelming. With these resources, you can learn at your own pace, explore real-world applications, and become part of a thriving community of innovators. In the next slide, we'll explore the steps to implement machine learning, taking what you've learned and turning it into actionable projects. Let's dive into the process of building your own ML models. Machine learning isn't just about algorithms, it's a journey. From identifying a problem to deploying a solution, every step is crucial. Think of it as building a house. You need a blueprint, materials, and tools, and each phase contributes to the final structure. Let's break down the 3 essential steps to implement machine learning effectively. Define the problem and objectives. Every great project begins with a clear purpose. What do you want to solve or achieve with machine learning? Here's how to start. Identify the problem. Are you predicting sales, detecting fraud, recommending products? Set objectives. What does success look like? Define measurable goals, like improving accuracy by 10%. Think of this step as the foundation. It determines the data you'll collect and the model you'll build. Example, a retail company wants to predict product demand to optimize inventory levels. The objective is to minimize overstocking and shortages, collect and prepare data. Just like a recipe depends on fresh ingredients, machine learning relies on clean, high-quality data. This step is all about gathering, cleaning, and preparing your data for analysis. Key actions include collecting data from relevant sources, e.g., databases, APIs, web scraping. Cleaning the data to remove inconsistencies, duplicates, and missing values, transforming the data into a format that's ready for modeling. Another example, for the retail company, this might involve collecting historical sales data, cleaning up errors, and standardizing formats across multiple stores. Select and train the model. Now comes the exciting part, choosing the right machine learning algorithm and training it to make predictions. Steps in this phase. Select the model type. Is it a classification problem, e.g. spam detection, or regression, e.g. predicting prices? Train the model. Use your prepared data to teach the algorithm patterns and relationships. Validate and test. Measure the model's performance on unseen data to ensure it generalizes well. One more example. The retail company might use a regression model to predict demand based on features like season, past sales, and regional trends. When these three steps come together, you create a powerful system capable of solving complex problems. But remember, machine learning is iterative. Models can always be improved with better data, more features, or advanced techniques. In the next slide, we'll explore the specific steps for deep learning, diving deeper into how neural networks take machine learning to the next level. Let's move forward. Let's explore the roadmap to implementing deep learning, a journey that begins with defining clear objectives and culminates in the deployment of powerful, optimized models. Step 1. Define the problem and objectives. The foundation of any deep learning project is understanding what problem you want to solve, whether it's image recognition, natural language processing, or predictive modeling. Defining clear goals and success criteria is key. Think of this as setting the destination before embarking on a journey. Step 2. Collect and prepare data. Deep learning thrives on high-quality, relevant datasets. This stage involves gathering and cleaning data, ensuring it's free of inconsistencies and ready for training. Proper preparation here is like fueling up your car. You can't make the trip without it. Step 3. Select the appropriate model. Architecture, choosing the right neural network. Architecture is pivotal. For example, convolutional neural networks, CNNs, for image tasks, recurrent neural networks, RNNs, for sequential data like text or time series, transformers for natural language processing. Selecting the appropriate architecture is like picking the right tool for the job. Efficiency and effectiveness depend on it. Step 4. Train, validate, and optimize. The model training involves feeding the model data and adjusting parameters to minimize errors. Validation ensures the model generalizes well to unseen data. Techniques like regularization and dropout prevent overfitting, ensuring the model is robust and ready for real-world application. This iterative process is the polishing phase, turning a rough diamond into a brilliant gem. Implementing deep learning isn't just about technical know-how, it's about strategy, precision, and adaptability. These steps provide a structured way to tackle complex challenges with the power of neural networks. Now that we've explored the steps to harness deep learning, let's shift gears to a broader perspective. How does AI fare when we examine its strengths, weaknesses, opportunities, and threats? Let's find out with a SWOT analysis. AI, like any transformative technology, comes with its own set of strengths, weaknesses, opportunities, and threats. Let's break this down systematically to see what makes AI a game changer, where it falters, and what potential it holds for the future. The strengths. Advanced problem solving. AI excels in processing massive datasets, identifying intricate patterns, and making predictions. It surpasses human capabilities in speed and scale. For example, in healthcare, AI models analyze complex medical imaging to detect anomalies faster than radiologists. Scalability. AI systems adapt across industries, whether optimizing supply chains in logistics, enabling predictive maintenance in manufacturing, or enhancing personalization in e-commerce. Imagine AI as a Swiss Army knife, versatile, powerful, and adaptable to numerous tasks. The weaknesses, data dependency. AI's reliance on large datasets makes it vulnerable to poor quality or biased data. Garbage in, garbage out. Flawed data leads to flawed outcomes. Interpretability challenges. Many AI systems, especially deep learning models, function as black boxes. Their decisions can be hard to explain, which poses ethical and operational concerns. The opportunities, market growth. With the global AI market projected to reach $390.9 billion this year, There's a goldmine of potential for businesses to innovate and invest. Industries like autonomous vehicles, agriculture, and retail are leveraging AI to unlock unprecedented efficiencies. Democratization of AI. Open source tools, cloud platforms, and accessible AI education are empowering small businesses and individuals to integrate AI without massive overheads. The threats, ethical concerns, and regulation. AI raises pressing questions about privacy, job displacement, and bias. Governments worldwide are crafting policies to regulate its use, which could slow adoption if not handled strategically. Cybersecurity risks. As AI-powered systems proliferate, they become targets for cyber attacks. The very tools meant to secure us could potentially be exploited. Welcome to the new era of video creation with Jog AI. Simply type your script to get started. All right, let's think about learning AI like building a pyramid. Each layer builds on the one before it, step by step, all the way to the top. It's about stacking your knowledge one level at a time. So let's climb this pyramid together and see how it all comes together. At the very bottom, we have the basics, understanding what AI actually is. Things like how it's different from traditional software and how machine learning fits into the bigger picture. This is like learning the alphabet before you start writing sentences. Essential stuff. Next, we move into data science. This is the fuel that powers AI. Without clean and structured data, AI is like a car with no gas. At this stage, you're learning how to collect, clean, and prep data and getting a grip on basic stats and probability. Think of it like setting up your kitchen before cooking. You need your ingredients, tools, and setup ready. Now we're stepping into machine learning itself, how machines actually learn from data. This layer is about understanding things like supervised and unsupervised learning, plus algorithms like decision trees and clustering. It's kind of like putting together furniture. You follow the instructions and start seeing how the pieces fit together. All right, now we're getting serious. This is where deep learning comes in and things get really interesting. Neural networks mimic how the human brain works. You'll explore stuff like CNNs for images or RNNs for sequences like speech or text. This is where AI starts doing some really cool human-like things, maybe even better. And finally, the top of the pyramid, mastery. This is where you're not just building AI systems, but thinking big picture, ethics, impact, and the future. You're diving into cutting-edge fields like generative AI or quantum machine learning. This is where you're not just solving problems, you're shaping the future. So now that we've climbed the AI learning pyramid, let's zoom in on machine learning specifically. How do you become an expert in this field? Let's break it down in the next slide. All right, let's zoom in on the machine learning side of things. Think of this as a more detailed map for climbing that AI pyramid we just looked at. Ready to scale this one? Let's break it down. First up, building a strong foundation with machine learning basics. This is all about understanding core concepts, things like linear regression, decision trees, and basic evaluation metrics. It's like learning how to ride a bike. You need to get the balance right before you start doing any tricks. Once you're comfortable with the basics, you move on to deep learning. Here's where it gets really exciting. You start working with neural networks and architectures like convolutional neural networks, CNNs, for image tasks, or recurrent neural networks, RNNs, for sequence data like language and time series. Think of it as upgrading from a bicycle to a high-performance car. It's a whole new level of capability. Welcome to the new era of video creation with Jog AI. Simply type your script to get started. All right, folks, imagine for a second that data science is like building a skyscraper. You don't just start with the penthouse suite, right? Nope. You need to lay a solid foundation and work your way up, floor by floor. This pyramid of data science skills is your blueprint to go from ground zero to standing tall in the field. Let's explore this one brick at a time. At the very bottom of this pyramid, we've got data manipulation basics. This is your entry point, where you get hands-on with data, cleaning it, organizing it, and making sense of it. Think of it like preparing your ingredients before cooking. If your data's messy, you're not getting a good result, no matter how fancy your model is. Tools like Excel, SQL, and Python's Pandas library are your best friends here. Now, moving up a level, programming skills. In today's world, if you want to call yourself a data scientist, you've got to be fluent in at least one programming language. Python and R are like the yin and yang of data science, powerful, flexible, and the tools behind most projects you'll work on. It's like learning how to use a Swiss Army knife, so many tools in one place, but you need to practice to know which one to pull out when. Next up, statistical knowledge. And let me tell you, this is where the magic starts to happen. Statistics are the backbone of data science. They help you understand patterns, make predictions, and even explain why certain trends occur. It's like learning the science behind your cooking, why baking powder makes a cake rise, or why some flavors work better together. Without stats, you're just guessing. With them, you're a data scientist. Now we're getting to the good stuff, machine learning proficiency. At this level, you're not just understanding the data, you're training it to do things for you. Want to predict customer churn? Recommend a new Netflix series? Spot fraudulent transactions? This is the level where it happens. Machine learning is like teaching your computer to think and act, and once you unlock this level, you're a data science wizard in the making. And finally, the Penthouse Suite, Advanced Analytical Techniques. Here's where you're taking it to the absolute next level. It's not just about making predictions anymore. It's about interpreting complex models, optimizing strategies, and applying cutting-edge methods like natural language processing or reinforcement learning. Think of this as turning that skyscraper into a futuristic building, full of smart technology that works seamlessly. You're no longer just analyzing data. You're creating systems that redefine how problems are solved. Do you see yourself climbing this pyramid? Picture where you're at right now. Maybe you're just laying the groundwork, or maybe you're already scaling the walls of machine learning. Wherever you are, the key is to keep building, one layer at a time, one skill at a time. Now that you've seen the skill-building roadmap for data science, let's switch gears and look at the milestones that shaped this entire field. Ready for a trip through time? Nice! All right, buckle up because we're about to take a journey through the history of AI. Think of it as flipping through a photo album of some of the biggest moments in artificial intelligence. These milestones didn't just push the boundaries of what machines can do, they completely redefined what we thought was possible. Our first stop is 1956, the Dartmouth Conference. This is where it all began, when the term artificial intelligence was coined. Picture a group of researchers brainstorming the future, wondering, can we make machines think like humans? This moment laid the groundwork for everything that followed, sparking decades of innovation. It's like planting a seed that grew into the vast AI forest we see today. Next, we fast forward to 1997. IBM's Deep Blue, a chess-playing computer, did the unthinkable. It beat world champion Garry Kasparov. Imagine this, the world's top chess player, utterly defeated by a machine. This wasn't just a victory for Deep Blue, it was a message to the world. Machines could now challenge human intelligence in ways we'd only dreamed of. It wasn't about chess, it was about the potential of AI. Now let's jump to 2012, a turning point in AI's journey. A team from the University of Toronto, led by Geoffrey Hinton, revolutionized image recognition using deep learning. They built a neural network that outperformed everything before it on the ImageNet challenge. This wasn't just an upgrade, it was a leap into a new era where machines could analyze images, videos, and data like never before. Think of this as AI getting its superpowers. Finally, we arrive at 2020, where OpenAI's GPT-3 shook the AI world. With 175 billion parameters, this model wasn't just smart, it was groundbreaking. From generating human-like text to revolutionizing chatbots and content creation, GPT-3 showed us that AI wasn't just assisting us anymore. It was collaborating with us. This wasn't just progress. It was a paradigm shift. Each of these milestones wasn't just a step forward. It was a giant leap that brought us closer to the AI we know today. It's like watching a child grow into a prodigy, with each moment building on the last. But what about machine learning specifically? Let's zoom in and trace the breakthroughs that made ML the powerhouse it is today. Ready? Let's dive in. All right, let's shift gears and dive into the timeline of machine learning, the core engine that powers much of modern AI. Think of this as tracing the path of a rocket as it climbs through the atmosphere, breaking barriers at every stage. All right, let's refine our lens and focus on the breakthroughs in machine learning itself. While some moments, like 1956 and 1997, overlap with AI milestones, here's how they directly shaped the evolution of machine learning. 1956, at the Dartmouth Conference, wasn't just the birth of AI, it was the moment machine learning became a concept. The idea of machines learning from data, not just executing pre-written instructions, took root here. It was the foundation upon which the entire field of ML was built. Fast forward to 1986, this is where machine learning truly flexed its potential. Backpropagation turned neural networks into learners, capable of adjusting their internal connections to minimize errors. It was a turning point, giving machines the ability to correct themselves and paving the way for modern deep learning techniques. Deep Blue's victory in 1997 wasn't just about AI beating humans. It demonstrated machine learning's capability to improve decision-making through strategic analysis of data. While not fully representative of modern ML, it highlighted the importance of algorithms learning and adapting under competitive scenarios. 2012 was a landmark year for machine learning. AlexNet, with its deep convolutional neural networks, didn't just win the ImageNet challenge, it proved the sheer power of deep learning. This wasn't just a small step, it was the moment machine learning leapt into the spotlight, driving applications in image recognition, language processing, and beyond. Finally, GPT-3 wasn't just an AI triumph, it was a masterclass in machine learning scale. By leveraging massive datasets and billions of parameters, it redefined how machines learn and process language, showcasing what's possible when ML operates at such an unprecedented scale. These milestones don't just tell a story of progress. They reveal how machine learning has continually redefined itself, evolving from abstract concepts to a force that drives modern technology. Data science has grown from a niche discipline into the centerpiece of decision-making and innovation. This slide gives an overview of key milestones that highlight its evolution into a critical field. As we've journeyed through the significant milestones in data science, from its origins to its profound transformations over decades, it becomes apparent that innovation doesn't exist in isolation. It's influenced by forces beyond technology alone: politics, economics, society, and more. This is where the PESTEL analysis comes into play. It's a lens that broadens our understanding of how AI's evolution is intricately connected to these external forces. So let's shift gears and dive deeper into the multidimensional factors shaping AI's present and future. Let's zoom in on the PESTEL framework. This analysis breaks down the broad factors influencing AI's growth and integration into our world. Each letter represents a pillar of this framework, and together they paint a vivid picture of how AI navigates the tides of change. The P for political, the role of regulation in shaping AI's trajectory. Imagine AI as a race car speeding toward the future. Government regulations are the guardrails that ensure it doesn't veer off the track. Initiatives like the EU's AI Act are perfect examples of how governments are stepping in to establish a legal framework for AI development and deployment. The goal? To foster innovation while protecting public interests. This is especially critical when dealing with concerns like bias in AI algorithms or the misuse of technology, such as surveillance systems. Governments worldwide are grappling with a tough question. How do you encourage innovation while ensuring accountability and ethical standards? The decisions made now will determine whether AI becomes a force for global good or a tool that exacerbates societal divides. The E for economic, AI's role as a catalyst for growth. Now, let's look at the numbers. The global AI market is projected to hit an astounding $390.9 billion by 2025. This isn't just a statistic, it's a reflection of how AI is reshaping economies worldwide. Think about the ripple effects, from autonomous vehicles streamlining transportation to precision farming boosting agricultural yields. AI is creating opportunities that were once the stuff of science fiction, but it's not just about profits, it's about jobs. While AI might automate certain roles, it's also creating a demand for skilled professionals in areas like data science, machine learning engineering, and AI ethics. The economic impact of AI is a double-edged sword, promising both growth and challenges. How we prepare for this shift will define the next decade of economic transformation. The S for social, the human side of AI. Here's where it gets personal. AI isn't just reshaping industries, it's reshaping lives. Whether it's personalized recommendations on Netflix or the life-saving potential of AI in healthcare, the technology is embedding itself in our daily routines. But not everyone sees AI as a blessing. Concerns about privacy, surveillance, and job displacement continue to spark debates. Public perception is complex. Some see AI as a helper, others as a threat. The challenge here lies in building trust. How do we ensure that AI is seen as a partner rather than an adversary? This is where transparency, fairness, and accountability come into play. The T for technological, the engine driving AI forward. Think of AI as a rocket. The advancements in machine learning algorithms and neural network architectures are the fuel propelling it forward. Innovations in areas like natural language processing, NLP, and computer vision have opened doors to applications we couldn't have imagined a decade ago. Take, for example, transformer models like GPT. These technologies are pushing the boundaries of what machines can understand and create. But here's the thing. While the technology itself is exciting, it's the applications of these advancements, like automating workflows, improving diagnostics, or enabling human-machine collaboration, that are truly transformative. The other E for environmental, balancing progress with sustainability. This is an often overlooked aspect of AI. Did you know that data centers powering AI applications consume 1-2% of global electricity? That's a staggering amount of energy. While AI promises efficiency and innovation, its environmental footprint is a growing concern. The challenge here is finding ways to make AI development more sustainable. Techniques like model compression and energy-efficient hardware are steps in the right direction. But the question remains, how do we balance the promise of AI with the need to protect our planet? The L for legal, the framework for responsible AI. Finally, let's talk about the law. AI operates in a gray area where innovation often outpaces regulation. Issues like intellectual property rights, data protection, and liability are becoming increasingly relevant as AI systems are deployed in sensitive areas like healthcare and law enforcement. Imagine a self-driving car causing an accident. Who's responsible? The manufacturer, the software developer, or the data provider? These are the questions legal frameworks need to answer. Companies must navigate these challenges carefully, balancing compliance with innovation to build public trust. The PESTEL analysis shows us that AI's journey is not just about technology, it's about navigating a complex ecosystem of external factors. From the political decisions shaping regulations to the environmental concerns driving sustainability efforts, AI is a product of its environment as much as it is a tool to transform it. Understanding these forces isn't just academic, it's practical. It helps us anticipate challenges, seize opportunities, and ensure that AI's impact is both profound and positive. So, as we move forward, let's keep this holistic view in mind. Up next, we'll tie it all together with a summary of how AI, machine learning, and deep learning are interconnected and why that matters. Let's take a step back and look at the bigger picture. What have we uncovered about AI, machine learning, and deep learning in this journey? Artificial intelligence, at its core, is the dream of machines that can think, reason, and learn. It's the umbrella concept, the spark that started it all. Under that umbrella, we have machine learning, the engine that powers AI's ability to adapt and improve. It's like teaching a child not just to memorize facts, but to understand patterns and use those patterns to make decisions. And then, within machine learning lies deep learning, the powerhouse of advanced algorithms that mimic the human brain. It's where machines dive deep into layers of data, learning to recognize faces, translate languages, and even generate realistic images. AI is the overarching goal, creating systems that can replicate human intelligence. Machine learning is the method, an approach to achieve that goal by letting systems learn from data. And deep learning is the cutting edge, a specialized subset of machine learning that thrives in processing unstructured, complex data. What does this mean for the real world? These technologies are not just theoretical, they're driving real change in industries around us. Autonomous vehicles rely on machine learning to navigate roads. Healthcare diagnostics are powered by deep learning to analyze medical images. Even the recommendations you see on Netflix or Spotify are results of algorithms learning from your behavior. These aren't just conveniences, they're life-changing innovations. AI is optimizing crop yields in agriculture, ensuring safer surgeries in hospitals, and bringing personalized education to students around the globe. And the best part? We're only scratching the surface. So, where does this leave us? AI, machine learning, and deep learning are evolving at a rapid pace, and the opportunities ahead are vast. But with great power comes great responsibility. The choices we make today, in terms of development, regulation, and application, will shape the AI of tomorrow. The challenge is to create a future where these technologies don't just advance, but truly empower humanity. And that's the story of AI, machine learning, and deep learning. From its conceptual beginnings to its transformative impact, this journey isn't just about machines, it's about us, our choices, and our vision for the future. As we stand on the brink of this revolution, the question isn't just what AI will do, but what we will do with AI. Thank you for being part of this exploration. Let's continue to learn, innovate, and build a future where technology is a force for good. The journey is far from over. This is just the beginning.